regulatory gene to make an active repressor. Next is the promoter. RNA polymerase gets stopped by the repressor, and it binds to the operator. No RNA is made, no proteins are made. Production is controlled. But when we have an inducer and an active repressor, no lactose, then RNA polymerase isn't stopped by a repressor. DNA is
transcripted.
Now the enzymes are used for lactose. They'll break it down into they don't belong there.
Hello everyone, thank you for listening to that comical opening provided by Kimberly. We hope you all enjoyed it, but now let's get more serious into the nitty-gritty portion of the Lac Operon and specifically look at if lactose is present or not present within the cell. But before we get any further, we have to look at the regulatory gene, also known as Lac-I from the Lac Operon, which is a little upstream from the promoter region of the in the operon. And we have to look after this gene is transcribed, it produces a single strand of mRNA, which is hence translated into a protein known as the repressor protein, which has allosteric properties. Now, that protein can follow two separate paths depending on if lactose is present or not present. And the first one we will focus on is its natural state when lactose is not present. When lactose is not present, the repressor protein maintains its normal shape and is hence able to bind to the operator of the operon. And when this happens, the RNA polymerase is unable to bind to the region because that repressor protein is present. So no transcription or translation can take place because RNA polymerase will not be able to produce any mRNA. And so this is a highly necessary process because lactose is not present, so it would be a waste to produce such enzymes without the necessary saccharide to break down. Now let's look at the second process, which is if an inducer is present, and more specifically if lactose is present. That inducer, allolactose from lactose, is able to bind to the repressor protein at the allosteric site and change that repressor's shape. When this happens, the repressor protein can no longer bind to the operator, and because of this, the RNA polymerase is now able to bind to the promoter region and move forward on with transcription of the functional genes. And because this is able to occur, we are able to look at transcription now occurring. When we look at this more in-depthly, the three structural genes, LAC-Z, LAC-Y, and LAC-A, after being transcribed, produce one strand of mRNA. And that one strand of mRNA is hence translated to produce three separate enzymes, beta-galactidase, permease, and transacetylase. And those three enzymes work together to break down lactose because lactose is now present within the cell. And when lactose is broken down, it is broken down into two subsequent monosaccharides, galactose and glucose. Those two saccharides are hence necessary for energy, which is why the whole process is taking place, or if there's simply just too much lactose within the cell. This constitutes the metabolism portion of the Lac Operon's purpose, and that's why it has evolved to be as such. Thank you for listening, and we will now provide you a short stop motion animation of the process as a whole. Thank you for listening.